In this the next example, we're going to be kind of building off of this one that we just did, where we're starting it over, but same directions, where we're going to have an acceleration equation. We're going to have an initial velocity given and an initial position given, and we want to find the very specific velocity function based on that initial value and find our position function based on that initial value. So we are going to take what we know, and we're going to do some antiderivative stuff. So to start with, to do acceleration, to do velocity, it's us taking the antiderivative of acceleration. So we're going to be doing the antiderivative of e to the negative t dt. All right, well, bad news is this is actually going to become a u substitution problem because I have a negative on this. And some of you might be okay just kind of knowing how this antiderivative is going to look. In case you don't, I'm going to let u equal negative t and du equal negative 1 dt. So if I pull that back over, a negative du equals dt. So what that means is I'm going to sub this and have an e to the u du, but so the du and the dt sub each other out, but I also have a negative that I'm just going to pull in front so I don't have to worry about it. And so then I'm going to do the antiderivative of that. Right, so the antiderivative of that is e, not there yet. Let me do the antiderivative first. So this is going to be an e to the u. Antiderivative of e to the u is e to the u. We're going to have a negative in the front, and then I'll sub back in my t. So I'll have a negative e to the negative t plus c. All right. So from there, this is where I use this initial piece of information. So at time 0, I'm going to plug in 0 for t. I'm going to set it equal to 60. So 60 equals negative e to the negative 0 plus c. Now, the only piece missing is going to be the c that I can solve for. So I don't really need the negative on that, but e to the 0, anything to the 0 is 1. So that's going to be 60 equals negative 1 plus c. We'll add the 1 over. So our c value is going to be 61, which means our velocity function is this, negative e to the negative t plus 61. So we're partway through. We wanted the velocity function based on that certain given information. We got it. So now let's do the position function. So position function is us doing, position function is s of t is going to be the antiderivative of our velocity function. So we're going to do the antiderivative of this, negative e to the negative t plus 61 dt. So if I do the antiderivative of e to the negative t, which I did right here, the antiderivative of e to the negative t goes to this, becomes that value. So if I ignore that negative for a second, the antiderivative of e to the negative t is negative e to the negative t with this extra negative kind of attached to it. So we'll clean that up in a second. Plus the antiderivative of 61 is 61t. And that is our position function with the c tacked onto it. So next part of this is, let's clean this up. Let's plug in our 0 for t and set it equal to 40. So we'll do that just a second. So we're going to have an e to the negative t plus 61t plus c. So that's almost our position function. Let's use this initial information. So 40 equals e to the negative 0 again, plus 61 times 0 plus c. So that's 40, that's 1, and that's 0. So we would subtract 1, giving us a c value of 39. So our position function, based on all this information, based on this being our velocity function, is this equation. e to the negative t plus 61t plus 30. All right, so that was using given information from acceleration, creating a velocity function, and then using that to create our position function.